Today, we're going to introduce the ProCision instrument. ProCision is honestly an amazing tool. One of its standout features is how it can quickly analyze and pinpoint those hidden issues that are usually tough to spot. It can dig through tens of thousands of test results and zero in on those rare but critical anomalies super fast. This makes it especially great for development stages where quality is a top priority. Next up, it visualizes measurement results, which is awesome. You get things like response time distribution charts that show the data spread really clearly. Engineers can just take one look and understand everything right away, saving a ton of analysis time. And when it comes to measurement accuracy, ProCision really shines. It measures response times with precision, which is crucial for ensuring a product's stability and consistency. Especially when you're trying to boost design reliability, this kind of high-precision capability is a huge help. Plus, it supports long-term data recording and works seamlessly with firmware tweaks. This means engineers can test small changes right away and see the results without waiting until the end to catch major quality issues. Honestly, that's pretty awesome. When it comes to ProCision's core strengths, another big one is how it integrates logic analysis, or what we often call LA. This makes it super versatile for testing needs at different levels and stages. Whether it's early validation or late-stage debugging, it's got you covered. And here's more, it can help with competitor analysis and performance comparisons. Need to check performance differences before and after a tweak, or stack your product up against others? ProCision handles it efficiently. It's a really handy tool for boosting development productivity. And last but not least, ProCision can fully monitor your system's behavior. It's especially great at catching those low-frequency but critical errors, making it the perfect assistant to ensure nothing abnormal slips through the cracks. When you open the box, you'll see it's packed with some really great stuff. First off, there's the main unit, of course, along with a USB 3.0 cable, which makes sure data moves fast and steady between your computer and the device. Then you've got the signal cables for picking up test signals. And they pair up with test hooks. You just clip them onto your test points and start watching the data. Super convenient. One cool thing worth mentioning is that it comes with two USB 1.1 measurement fixtures. These are perfect for testing low-speed USB devices, giving you more precision and solid data for validation. Plus, there's a handy USB drive included, loaded with drivers, the software, and a full user manual. Even if it's your first time, you'll get the hang of it in no time. And on top of that, it comes with an original factory warranty and tech support. If you run into any issues, you can reach out to us directly. No need to stress about follow-up problems. That's honestly pretty awesome. Setting up ProCision is actually super easy. No complicated steps needed. It works with operating systems from Windows 7 all the way up to Windows 11, so pretty much any version you're using now is covered. First, head over to the Zero Plus official website to download the software. I'd suggest bookmarking that page. It'll make finding updates later a breeze. Once it's downloaded, just follow the instructions step by step, and you're good to go. Quick tip: before you start installing, it's a good idea to close any other programs you've got running. It helps avoid any hiccups. Next, unzip the downloaded file, then run the setup.exe inside. The screen will ask what you want to do. Just pick Application Setup and hit Next. After that, you'll see the license agreement pop up. All you need to do is choose Accept, and you're ready to keep going. After that, enter your username and company name. It's just for registration and won't affect anything. Then, for the setup type, go with Complete. That's the full installation, so you'll get access to all the features. Finally, it'll automatically install the drivers for you, which is honestly super thoughtful. And the best part? You don't even need to restart your computer. Once it's done, you can start using it right away. So convenient. Before we dive in, let's take a quick look at how to set up the hardware environment. First up is the USB 3.0 interface. It's not just for transferring data, it's got a few key roles. It lets your computer control the instrument's operation mode, like starting or stopping measurements. At the same time, it quickly sends the data the instrument captures back to your computer, so we can see the results in real time. Plus, the USB also powers the instrument, so you don't need an extra power cord. Honestly, that's super handy. Next up is the signal interface for the device under test, or DUT. This is where you connect the circuit or device you want to observe, and it's got a few key input and output points. First, there's the signal input. This is the main source of the data you're measuring. Then there's the ground connection, which is super important. It ensures the instrument and the DUT share a common reference point, so you don't get noise or messed up data. After that, it also supports an external clock input. So, if you've got a specific clock source, you can use it to sync your measurements. Really helpful for high precision stuff. There's also external trigger input and output. This lets the instrument start capturing data when a specific event happens, or you can pair it with other devices for synchronized testing. And finally, it's got signal output. That means you can have the instrument send out specific signals to simulate or control external devices. With all this combined, your testing gets way more flexible and powerful. Honestly, it's pretty awesome. Just got the instrument and want to get started fast? It's actually really simple. First step, connect the rainbow ribbon cable to the digital signals you want to measure. Those are the output pins from your device under test. Make sure to hook up the ground wire too, so your measurements stay accurate. You can also use the test hooks to clip onto the signal lines. It makes things a lot easier. Next, let's open the software and set up the recording mode. First, pick how many channels you want to use, like 8 or 16 channels. Then, choose a good sampling frequency. This affects how much detail you can see in the signal. Usually, you'll want it to be at least 6 times the frequency of your device under test. And finally, set the recording duration, so you decide how long of a data chunk you want to capture. Once everything's set up, you're ready to start recording. Just hit the single capture button, and the instrument will start grabbing data. You can also check the long time record data monitor section to see the recording progress. It's pretty straightforward. After recording the data, we can dive into some deeper analysis. Just hit the Pair Analysis button. And you can set up conditions for paired analysis, like figuring out how the test signals match up. Finally, if you want to save or share your test results, just hit the Save button. It'll store not only the data but also all the related settings. Super thoughtful, right? Before you start using the instrument, here are a few handy tips to make your measurements smoother and more reliable. First off, make sure to wear an anti-static wrist strap. This is super important, especially when dealing with sensitive circuits. It really helps prevent static from damaging components. Next, there's a little trick to setting the sampling frequency. Try aiming for about 6 to 10 times the frequency of the signal you're testing. That way, you'll capture enough detail and accuracy to make the data actually useful, right? After recording, always save your files. It's not just about keeping the analysis results, you'll also have them handy for double-checking or comparing later on. And one last key tip, make sure the computer doesn't interrupt the instrument by going into sleep or power-saving mode. I'd suggest turning off your computer's sleep function altogether. It keeps everything stable, especially during those long recording sessions. This tool is seriously powerful. It's packed with features and super intuitive to use. For example, when you're analyzing stuff, you can set input and output conditions, and even let the system automatically search for the data you're after. That's just so convenient. It's also got a really solid response time stats feature. Think averages, maximums, and even sorting, so you can spot outliers at a glance. You can set specific response time ranges too, and the system will crunch the numbers for that section for you. No need to calculate it all yourself, which saves a ton of time. And the best part? It's got this response time histogram that lets you compare two groups side by side. That kind of comparison is honestly so practical. Now, let's talk about some of the other cool options. It supports a multi-language interface, so engineers from any region can jump right in with ease. You can also export and import settings files, meaning you can take your go-to analysis setups with you. Talk about a huge efficiency boost. Plus, you can customize the toolbar, putting your favorite functions right where you want them, which makes everything feel so much smoother. And there's more. It's got signal processing features like noise filtering. That's super helpful when you're dealing with a lot of noise, cutting out interference so your data comes out cleaner and more accurate. Next, let's go over a few use cases, starting with a single key example. This is perfect for products with key designs like mechanical keyboards or instrument panels. You can use it for key testing, tracking from the very first press all the way to the 10,000th, watching how the bounce changes over time. That's super helpful for figuring out the key's lifespan and stability. You can see if it slows down over time or if noise starts creeping in. Plus, it lets you check if every key produced has consistent stability, which is honestly crucial for mass production. And the best part? All that data you collect can go straight to hardware engineers, firmware teams, or even quality assurance to tweak the design. It's especially great for companies wanting to track mechanical keyboard performance, giving you the real story behind every single press. First, let's talk about the hardware setup. Let's say the device under test is a push button. In that case, we'll connect the button's output to channel A0 of the instrument. Also, don't forget to add a pull-up resistor on the button side, and make sure to connect the ground wire as well. Next, let's set up the automatic button pressing machine. We'll configure it to press the button 4 times per second. Then, we adjust the distance between the machine and the button, and make sure both are securely fixed in place. This helps ensure stability during the measurement process and improves the accuracy of the results. Now, let's go over the software operation. Once you launch the software, just click on Acquisition Setup to configure the recording settings. Here, we'll select 4 channels, set the sampling rate to 10 MHz, and set the recording duration to 1 hour. Next, when you click the single capture button, the data recording will start. All you have to do is wait until the recording reaches 100%. Once it's done, don't forget to hit save to store the data and related settings. That way, you won't lose any of your results. Once the recording is complete, we can move on to further analysis. Click on Pair Analysis to set up the pairing analysis conditions. Here, you can choose the pairing mode as backward find input signal after output signal found. Then, set the input condition to trigger when the signal goes from 1 to 0, and the output condition to trigger when it goes from 0 to 1. After clicking Perform Pair Analysis, the software will start the analysis. Once completed, the number of results that meet the set conditions will be displayed in the results field. This time, a total of 14,000 states were found to match the conditions, so you can clearly see each result. You can also set up multiple groups to analyze several conditions at the same time. Additionally, in the Classification Statistic window, you can adjust the analysis range. Once you've set it up, just click Perform Classification, and the system will automatically update the number of results that meet the conditions within that range. This helps you get a clearer and more precise understanding of how quantities are distributed across different ranges. It's worth noting that out of the 14,000 cases, there were 2 instances where the response time exceeded 5 milliseconds. Finally, make sure to use the histogram distribution chart. In the chart, you can display the status of both groups at the same time, making it easy to compare differences. The 0.01% of cases exceeding 5 milliseconds will also stand out, so you can quickly get a clear picture of the overall situation, making your analysis much more straightforward. If you want to quickly identify the worst-case scenario, you can use the response time sorting function. This will help you find the longest bounce time, also known as the state with the most significant bounce. Just click on the table below, and the waveform area above will automatically jump to the selected time point. The second case is about firmware using polling and interrupt modes to scan keys. On the hardware side, an automatic key pressing machine hits the key 4 times a second. We connect Arduino's pin 2 to the LA's A0, that's your key input signal. Then, Arduino pin 3 goes to LA1, which is for the output when scanning the key with polling. Arduino pin 4 hooks up to LA2, and that's for scanning the key output using interrupt mode. Finally, Arduino pin 5 connects to LA3. This one shows the time it takes for the firmware to process the key press. Next up is the software part. After opening the software, we click on Acquisition Setup to set the recording conditions. Set it to 4 channels, with a sampling frequency of 5 MHz, and a recording time of 5 minutes. This setup makes sure we capture enough data for later analysis. Once the setup is complete, click the Perform Pair Analysis button to start analyzing the data. The results will be shown in the Results field, where you can clearly see that a total of 1,199 key press events were recorded this time. Next, let's take a look at the recorded results. In polling scan mode, the response time is evenly distributed between 0 and 10 milliseconds, which is actually pretty normal and shows the stability of the scanning process. However, in interrupt mode, all response times are below 2 milliseconds, with an average response time of 7 microseconds. That's really impressive and shows just how fast the interrupt method responds. Lastly, if the key press duration is shorter than the scan cycle, polling mode might miss the key press. In this test, for example, about 6% of key presses were missed, which is something to watch out for. This is especially important during rapid key presses, where you might need to adjust the scan speed or switch to interrupt mode to avoid missing any key presses. Let's take a look at this keyboard response speed comparison. We'll be pressing the plus key 4 times per second. For this test, we're using 2 keyboards. The first is the L Brown K120 USB keyboard, and the second is the G Brown K6150 USB keyboard. Our main focus is testing the response speed of these 2 keyboards. Next is the software part. After opening the software, click on Acquisition Setup to set the recording conditions. Set it to 4 channels, with a sampling frequency of 5 MHz, and a recording time of 5 minutes. This ensures we gather enough data for analysis. Then, we need to set up the USB 1.1 bus in the software. This makes sure we can properly decode and capture the data. When we press the plus key, the third byte in the USB data packet will change, and we can use this as the output condition. Next, click the Perform Pair Analysis button to start the analysis. You'll then see the results displayed in the Results field, clearly showing that 1,255 key press states were recorded and analyzed this time. Regarding the recorded results, the average response time for both keyboards is about 15 milliseconds, with a difference of roughly 1.6 milliseconds. Specifically, the K6150 keyboard has a slightly better average response time than the K120 keyboard. However, its response time distribution is more scattered. In comparison, the K120 keyboard, which analyzed a total of 14,000 states meeting the set conditions this time, has a more concentrated distribution. If you have any questions, you can check out the latest course updates and product info on Facebook. For urgent issues, feel free to add us online there. You can get instant help and tech support. And on YouTube, you'll find even more technical resources and handy tips to help you get the hang of things faster.